Dear students, today I am going to explain a theorem on similar triangles. Okay. Before going to explain this theorem, I would like to recall a few points related to this theorem. Mainly, you have to know about similar triangles, meaning of similar triangles, okay, corresponding angles, corresponding sides, and the meaning of proportion. See, first I recall the meaning of similar triangles. Okay, see, here you see two triangles, ABC and DEF. In these two, angle A and angle D are equal to 60 degree, angle D, angle E are equal to 40 degree, and angle C, F are equal to 80 degree. That means here angle A and angle 2, which are equal to 60 degree, are called a pair of corresponding angles. Similarly, angle B, angle E, 40 degree, and angle C, angle F is equal to 80 degree. In these two triangles, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. So these are called pair of corresponding angles. Okay, after this corresponding sides. Remember, sides opposite to the corresponding angles are corresponding sides. For example, let us consider these two angles, angle A and angle D. Here side opposite to angle A is BC, and here side angle opposite to D is EF. So BC and EF are a pair of corresponding sides. If you consider B and E, side opposite to B is AC and side opposite to E is DF, and this is AC, okay, AC, DF, another pair of corresponding sides. And look at this angle, CF. Here side opposite to C is AB and side opposite to F is DE. So sides opposite to corresponding angles are called corresponding sides. What are corresponding angles? Equal angles in two triangles are corresponding angles. So now let me tell you the meaning of similar triangles. Here ABC and DEF are called similar triangles. See, in two triangles, if corresponding angles are equal, then the triangles are said to be similar triangles, or corresponding angles must be equal. Here you have to remember 2 points. Two triangles are said to be similar if and only if their corresponding angles are equal, corresponding sides are proportional. Corresponding sides should be in the proportion. So I told that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Now the angles of ABC are equal to angle DEF. These two triangles are equiangular triangles, is it not? Remember, equiangular triangles are also similar triangles. Okay, I told two conditions, either that or this. Two triangles are said to be similar if their corresponding sides are proportional or corresponding angles are equal. Now let me tell you the meaning of proportional. Just recalling, equality of ratios. Okay, if ratios of corresponding sides are equal, then we say that they are in proportion. Okay, now let me get into the theorem. First I tell you the summary of the theorem. Areas of similar triangles are proportional to square of their corresponding sides. Look at this. Areas of similar triangles are proportional to square of their corresponding sides. Now I am going to prove this theorem. Okay, firstly let us consider two similar triangles. All of you got the meaning of similar triangles. Okay, in two triangles, if corresponding angles are equal or corresponding sides are proportional. Okay, now let us consider two triangles. Okay, ABC and DEF. ABC and DEF. I told that these two triangles are similar triangles. So that you have to mention in data. First step, ABC and DEF are similar triangles. That means what? Their corresponding angles must be equal. Angle A is equal to angle DR. You can call it angle BAC is equal to angle EDF. Secondly, angle ABC is equal to angle DEF. And thirdly, angle BCA is equal to EFD. So that you have to write in this point data. Okay, write like this: triangle ABC is similar to triangle DEF. Okay, what this symbol denotes? Similarity. Similarity of triangles. ABC, triangle ABC similar to triangle DEF. Now let us write corresponding angles here. Angle ABC and angle DEF, a pair of corresponding angles, DEF. Next, angle BAC. BAC is equal to EDF. BAC is equal to EDF. And BCA, angle BCA is equal to BCA, this one, BCA is equal to EFD. Now we have to list the corresponding sides. First let's begin with these two angles. Angle BAC, angle EDF. Here side opposite to BAC is BC, and here side opposite to EDF is EF. So BC and EF are a pair of corresponding sides. Write like this: BC by EF, okay, is equal to, next let's consider these two angles. Angle BCA, angle EFD. These are another pair of corresponding angles. Now what is the side opposite to this angle? AB, and here side opposite to EFD is DE. AB by DE. Okay, and now ABC and DEF. What is the side opposite to ABC? AC, and here DF. AC by DF. So this is data. Okay, the two triangles are similar triangles. We have listed the corresponding sides as well as corresponding angles. Now, to prove, what you have to prove here? The ratio of areas of two similar triangles is equal to square of their corresponding sides. In other words, the areas of similar triangles are proportional to square of their corresponding sides. So, area of triangle ABC by area of triangle DEF is equal to, you have to find the areas of these two triangles. Their ratio, the ratio of areas of two similar triangles should be equal to what? Square of their corresponding sides. You can consider any pair here, BC and EF, a pair of corresponding sides. So BC square by EF square. This we are going to prove. Areas of similar triangles are proportional to square of their corresponding sides. Okay. Next step is construction. Let us draw AL perpendicular to BC and DM perpendicular to EF. DM perpendicular to EF. That you have to mention here. Draw AL perpendicular to BC and DM perpendicular to EF. Now, when we draw two perpendiculars, you see formation of triangle ABL, or we can call it ALB and DME, which are right angle triangles. Okay. Let's move to next step. What is that? Final one now. Proof. Now I am considering these two triangles, triangle ALB and triangle DME. In triangle ALB and triangle DME. So here you know that angle ABL is equal to angle DEM. It is given. Angle ABL is equal to angle DEM. In bracket data. ABL is equal to DEM. Secondly, angle ALB is equal to angle DME. Angle ALB is equal to angle DME is equal to 90 degree. Because construction AL perpendicular to BC and DM perpendicular to EF, that you have to mention here. Because AL perpendicular to BC and DM perpendicular to EF, or simply write construction. Okay. Now, therefore, ALB is similar to DME. Okay. Equiangular. In the beginning I told this. If two triangles are equiangular, then the triangles are said to be similar. So here ALB is equal to, triangle ALB is similar to triangle DME. So now we proved that ALB and DME are similar triangles. Okay? Because you proved that they are equiangular. Look at this. ABL is equal to DEM. ALB is equal to DME. AA criteria. Basing on this, we say that triangle ALB is similar to triangle DME. Now we have to list the corresponding sides. Okay, corresponding sides. Look at this. ALB is equal to DME. What is the side opposite to ALB here? AB, and here DE. AB by DE. Okay, and nextly this one. These two angles are equal. What is the side opposite to it? AL, and here DM. This is another pair of corresponding angles. AB by DE is equal to AL by DM. Okay, corresponding sides. But what you learned from data? AB by DE is equal to AC by DF. BC by EF is equal to AB by DE. From data we learned this. In the beginning I told that these two are similar triangles. Side AB is proportional to DE, and side AC is proportional to DF, and BC is equal to EF. So AB by DE is equal to BC by EF. Now AB by DE is equal to BC by EF is equal to AL by DM, because Axiom 1. What Axiom 1 says? Things equal to the same thing are equal to one another. Look at this. AL by DM is equal to AB by DE, and AB by DE is equal to BC by, that means AL by DE and BC by EF both are equal to AB by DE. Therefore we say that AB by DE is equal to BC by EF is equal to AL by DM. Axiom 1. Things equal to the same thing are equal to one another. Okay, so here AL by DM and BC by EF are equal to AB by DE. Therefore we say AB by DE is equal to BC by EF is equal to AL by DM. Okay, now we have to find the areas of triangles. Area of, short form, area of triangle ABC by area of triangle DEF is equal to, how do you calculate the area of triangle? Area of triangle is the half the product of their base and height. Half into base into height. Okay, 1 by 2 into, in triangle base is BC and height is AL. BC into AL, half into base into height, by area of triangle DEF is equal to base is EF and height is DM. 1 by 2 into base is EF into height is DM. Look at this. 1 by 2, 1 by 2. 1 by 2, 1 by 2 cancel. BC by EF into AL by DM. Okay. Earlier we proved that AL by DM is equal to BC by EF. Therefore, I write BC by EF into, instead of AL by DM, BC by EF. BC by EF into AL by DM Earlier we proved that AL by DM is equal to BC by EF. Therefore, I substituted BC by EF for AL by DM. Now, BC into BC is BC square by EF into EF is EF square. Therefore, areas of similar triangles are proportional to square of their corresponding sides. So, this is a theorem based on similar triangles. Okay, areas of similar triangles. Look at this, we are given two similar triangles ABC and DEF. The ratio of their areas are always equal to square of their corresponding sides. BC and EF are a pair of corresponding sides. So, areas of similar triangles are proportional to square of their corresponding sides. Now, let us solve a few riders based on this theorem. Okay, so if we work on a few problems, we get idea about the theorem. Now, here is a problem. Triangle ABC is similar to triangle DEF. Okay, that means ABC and DEF are similar triangles, and the ratio of corresponding sides is 2.5:5. Okay, and the area of triangle ABC is 120 square centimeters. Find the area of DEF. You have to find the area of DEF. Observe the question once. ABC and DEF are similar triangles, and a pair of corresponding sides BC, EF are in the ratio 2.5:5, and the area of triangle ABC is 120 square centimeters. Here you have to find the area of triangle DEF. Okay, so let's apply the theorem we learnt. Okay, what the theorem? What is the summary of that theorem? Area of similar triangles are proportional to square of their corresponding sides. Okay, area of triangle ABC by area of triangle DEF is equal to square of their corresponding sides. Okay, what are the corresponding sides here? BC and EF. BC square by EF square. Just a theorem. Now let's substitute the values. You are given the area of ABC. What is the area of ABC? 120 square centimeters. Remember, area should always be expressed in square units. Square centimeters, square meters. Okay, area of ABC is 120 square centimeters by area of DEF is equal to, okay, BC is 2.5 by EF is 5 square. Now 120 by area of DEF is equal to 2.5 square of 2.5. 2.5 into 2.5 is 6.25. 25 is 625, is it not? So 2.5 into 2.5 is 6.25 by square of 5 is 25. Observe this. 120 is equal to 625. Area of DEF is equal to by 25. Here I removed the decimal. Decimal is after 2 digits. That's why here you have to write 2 zeros. Okay, 5 ones are, 5 twos are, 5 fives are, 5 fives are 25, 0, 0. Now 5 twos are, 5 fives are, 5 ones are 0, 0. 25 ones are, 25 fours are. So area of DEF is equal to 124 into 120 into 4. I continue here. Area of DEF is equal to 120 into 4. 4 zeros are 4 twos are 8, 4 ones are 4. So area of DEF is 480 square centimeters. Okay. Now let me solve the next rider. Here ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR, and area of triangle ABC is equal to 36 square centimeters, and area of triangle PQR is equal to 25 square centimeters. If QR is equal to 6 centimeters, find the length of side corresponding to it. Side corresponding to it. So here areas of two similar triangles are given. Which are the two similar triangles given here? ABC and PQR. Okay, these are similar triangles. Their areas are given. Okay, area of triangle ABC by area of triangle PQR. So let us consider a pair of corresponding sides. Let us consider BC and QR. Okay, BC square by QR square. Now let us substitute the values. What is the area of ABC? 36 square centimeters by PQR is 25 centimeters square centimeters is equal to, what is the length of BC? We have to find BC square by area of length of QR is 6 centimeters. 6 square. So 36 by 25 is equal to BC square by, okay, square of 6 is 36. Now last step, BC square is equal to 36 into 36 by 25. What do we need? BC. BC is equal to transpose the square 36 into 36 by 25. So square is transposed, it becomes a square root. So what is the square root of 36? 6 by 5. So 36 by 5, 6 6 are 36. 36 by 5. 36 by 5 means how much? 36 by 5. 5 7s are 35. 5 2s are 10. So is equal to 7.2 centimeters.